Hello my dear students. Today we will discuss the most interesting topic of chapter 2, which is distance, displacement, speed and velocity. So very first we'll start with distance and displacement. Distance, the total length of path through which a body moves, is called distance traveled by the body. It is a scalar quantity and it depends upon the path followed by the body. The unit of distance is meter. Suppose as you can see in this diagram, so the blue dotted line represents the distance. Now displacement. The shortest distance from the initial point means the point from which we start our journey. That is called initial point, and final position is where we end our journey. So the shortest distance between the initial to the final position of the body is called displacement, and its direction is from the initial to the final position. It is a vector quantity. Its SI unit is meter. Since we are measuring the distance, so its SI unit will be meter. So this is an again example of distance and displacement. This 200 meter is the example of distance, and 120 meter, the shortest distance between this home and the factory, which is representing the displacement of the body. Now, how to represent displacement? The displacement, being a vector quantity, is represented by the straight line with an arrow. As you can see, this arrow, the tip of the arrow on the straight line represents the direction of the displacement, while the length of the straight line on the proper scale represents its magnitude. So from tail to head, so this represents magnitude and this tip of the arrow is representing direction. This is how we represent a vector quantity. An arrow on the head which represents a vector quantity. Now next is difference between distance and displacement, the most important one. First point, it is the length of the path followed by the body, actual distance followed by the body. Displacement, the shortest distance between the initial and the final position, is called displacement. Point number 2, it is a scalar quantity, it has only magnitude. Point number 2 in displacement, it is a vector quantity, so it has both magnitude and direction. Point number 3, distance, it depends upon the path followed by the object. Point number 3, in displacement, it does not depend upon the path. It's only depend on the initial and the final position, shortest distance between them. Distance is always positive. Displacement can be positive, negative or zero. Negative means depending upon the direction. Okay. Now, point number 5. It can be more than or equal to the magnitude of displacement. In point number 5 of displacement, its magnitude can be less than or equal to the distance but can never be greater than the distance. Point number 6. It may not be zero even if the displacement is zero. But it cannot be zero if the displacement is not zero. Point number 6 of displacement, it is zero if the distance is zero, but it can be zero even if the distance is not zero. So I am giving you an example of when a body is zero, having displacement zero. Suppose when we throw a ball in vertically upward direction, and after some times it comes back in your hand, so its initial point and final point is same, hence it is an example of zero displacement. Second example also you can take, the motion of a body in a circular path. That means your starting point and final point and end points will be same. Then in circular path also it is an example of zero displacement. Moving on to the next topic, speed and velocity. Speed, it shows how fast you are traveling. Velocity, speed in a given direction. When direction is added, it becomes velocity. Speed. The speed of a body is the rate of change of distance with time. It is a scalar quantity. We represent it with V, distance as S, and time as T. So speed is equal to distance by time. Now about its unit. The unit of distance in SI is meter and time is second. So its SI unit is meter per second and in CGS it is centimeter per second. Next is uniform speed. Uniform speed means a body is said to be moving with a uniform speed when it covers equal distance in equal interval of time throughout its motion. Suppose I am explaining this with this graph. On this graph, here on x-axis we have time and on y-axis we have distance. Okay, so time in minutes 1, 2, 3, 4, 5 and 6, and here distance in meter up to 16. So in 1 minute the person is traveling 10 meters, 2, 20, 3, 30. That means after a gap of every 1 minute the person is traveling an equal distance of 10 meter. 60 minus 50, 10, and time 6 minus 5, 1. So here equal interval of time is there, traveled, body is traveling an equal distance. So this is the example of uniform motion. Non-uniform motion. Non-uniform motion means variable motion. That means a body is said to be moving with non-uniform motion if it covers unequal distance in equal interval of time. As time has a fixed interval, so it will move on with the same speed. Here distance is varying. So in first second, as you can see, first minute the body is here near about 10 second. In this graph you can see the zigzag paths which indicates the distance traveled by the body is varying after every 1 minute. So with the help of this graph you can understand non-uniform motion. That means the body is traveling unequal distance in equal interval of time. Moving on to the next topic, instantaneous speed. So instantaneous speed is when the speed of a body keeps on changing. Its speed at any instant is measured by finding the ratio of the distance traveled in a very short time interval to the time interval. This is called instantaneous speed. Distance traveled in a very short time interval by the time interval. Average speed. Next is simple, total distance traveled by the body by total time taken. To calculate average speed, total distance traveled by the body by total time taken. This is how we can calculate the average speed of the body. Now moving on to the next topic, velocity. Velocity. The velocity of a body is the distance traveled per second by the body in specified direction. Here direction added, hence it becomes a vector quantity. So we represent an arrow over the V which indicates velocity, which is equal to displacement by time taken. Displacement again a vector quantity, so an arrow on the S. So this is the formula for velocity is equal to displacement by time. Unit of velocity. Displacement is also the measured in length, distance. So its unit is meter per second in SI and centimeter per second in CGS. Similarly, uniform velocity. If a body travels equal distance in a particular direction in equal interval of time, the body is said to be uniform velocity. Non-uniform velocity. If a body moves unequal distance in a particular direction in equal interval of time, but its direction of motion does not remain same, the body is said to be variable or non-uniform velocity. Now to calculate average velocity is the displacement by total time taken. An example of a uniform velocity is the raindrops reach on the surface of the earth falling with uniform velocity. Similarly, an example of non-uniform velocity or variable velocity is that a motion of a freely falling body with a variable velocity, although the direction of motion of the body does not change, but the speed continuously increases. Similarly, the motion of a body in a circular path, even with uniform speed, is with variable velocity, because in circular path at every point the direction of the body is changing. Now next, difference between speed and velocity, again a very important topic. Speed is the time rate of change of distance of the body. You can write the definition as the very first point in both the cases. Speed is a scalar quantity, velocity is a vector quantity. Speed tells nothing about the direction of motion of the body. Velocity tells the direction of motion of the body. Speed of a body can be positive or zero. Velocity of a body can be positive, negative or zero, because displacement can be negative, positive or zero. Similarly, velocity can also be positive, negative or zero. Average speed of a moving body can never be zero. Average velocity of a moving body can be zero, because the formula of average speed is equal to total distance traveled by body by total time taken. So distance can never be zero, hence average speed of a moving body can never be zero. Average velocity of a moving body can be zero, because displacement by total time taken, the ratio of average velocity is displacement by total time taken. So displacement can be zero, as in the example of circular motion, displacement can be zero. If our initial point and end point is same, then we can say that displacement is zero, hence average velocity is zero. So learn this difference. Next topics will discussed in the next video along with the numericals. Thank you.